I almost thought we were not gonna come back, but hey, I'll tell you, but it's a story for another day. What's up, everybody? Welcome back to yet another episode of Basic Chemistry 101 with Sihlebonani. My name is Sihlebonani, and it's over 100 and something days since we did part 1 of naming basic compounds. Let's go.
This is for every child that wants to make it one day. Mzimbo class and presence of mind is elsewhere. Swinga uzuzani afuna kudle already alisipani and the timer is nowhere. I know your pain, you don't have to be scared. The dreams are very pure, lay the written and focus. Keep that pen and paper, they will take you to that day. In the meantime, stand up, help me.
We're back now. We've dealt with ionic compounds. Now we're doing molecular compounds. But what you'll have to note for this one, we are doing binary molecular compounds. What are binary molecular compounds? Okay, binary compounds, it's compounds of just two elements. An example would be carbon and oxygen. That's a binary compound because it has two elements. Now, since we are dealing with molecular compounds, when you write a formula, you have to start with one of the two. Now, how do you know? Now, it's a matter of the non-metallic character of certain compounds. So, the more it becomes non-metallic, the more it becomes the last compound, or the more it becomes the last element in the compound. So boron is more metallic than carbon, and carbon is more metallic than oxygen. So boron, if it's boron and carbon, would be the first priority. And if it's carbon and oxygen, oxygen will be the last priority if it's carbon and oxygen, because oxygen is more non-metallic compared to carbon. So there's an order there of which element should come first. But you would if you study more on how this thing is actually prioritized, you'd notice that in a period, across the period, the non-metallic character increases, so the priority across the period will decrease. So group 3 will start before group 4, and so on and so on. But there are exceptions, of course. So the priority across the period decreases, but the priority down the group increases. Priority across the period decreases, down the group increases. That just bites this up. But again, priority. Kalango group 3, 4, 5. However, you have to note that there is oxygen and fluorine that are exceptions. Fluorine is the last. Whatever compound you have, chlorine will be the last priority. So you'll start with the element which is bonded to fluorine, then fluorine will be the last one. Then oxygen is the second last in the priority. Everything would stay the same. And then there's also an element which is grouped not in the space of your nonmetals, which is your hydrogen. Now, hydrogen becomes a problem. Where do you group it? In that order of priority, you'll have to group it between group 5 and group 6. So hydrogen will have a lower priority compared to group 5, group 4, and group 3. But will have a higher priority compared to group 6 and group 7. So you will have a a boron hydride, but you will have a hydrogen oxide. That is how you would prioritize. We'll put the, what is this thing, the order here. Order here. Okay, now since that is out of the way, if you did not get it, rewind and start again. There are rules to naming simple molecular compounds. Number one, the name of the formula follows the order. If you have carbon and oxygen, based on that priority we talked about, carbon will come first, then you'll have oxygen. So your name would be carbon, oxygen. We haven't named yet, but the order will go with carbon and then oxygen. The first element is named as it is. So carbon is named as carbon. And then the second element will be, remember when we spoke of anions and how they end with "ite." So the second element will have a suffix of "ite." So if I have carbon, I name it as it is, and then oxygen will be oxide. So I have carbon oxide. That is rule number one. And rule number two, rule number one is you name it in that order. Rule number two, the first element, you name it as it is. And then rule number three, the second element, it ends with an "ite." Then rule number four, you will find that your elements have subscripts. An example would be CO2. That 2 written as a tiny 2 just below oxygen. That is your subscript. So you'll be using, remember when we spoke about prefixes, that subscript, you will have to let it be known that there is a subscript. So if you have CO2, carbon is 1, and then you have 2 oxygen atoms. But the 1 in carbon will not be written. So you'll have carbon dioxide. It's like that. But if you had a subscript if you had a subscript in carbon, let's say you have C2O2, there's no such thing as that. But for an example, if you had C2O2, you'd have dicarbon dioxide. So the subscript in molecular compounds is important, so it must be noted. So now that is how you would name your molecular atoms. That is actually it. 1 follows the order of how the elements are written. 2, the first element is named as it is. It's carbon, mono or dicarbon or tricarbon, depending on the subscript. Then the second element is given an "ite." So it's oxide or dioxide or trioxide, depending on the subscript that you are given. However, you'd find that when we are talking of those, let's say oxygen or your oxide, you have 4 oxygen atoms in your compound. Now that would be your tetraoxide. But tetra ends with a vowel and oxygen starts with a vowel. So usually the last vowel in the prefix is usually dropped and you'd have tetroxide. Hope that makes sense. But hey, there are well established names that you will have to learn, like your H2O is your dihydrogen oxide, but you know it has water. And you have NH3, which is, if we're using these rules, it would be nitrogen trihydride, but that's ammonia. And you have H2S. If we're using the rules, that would be dihydrogen sulfide, but it's mostly named as hydrogen sulfide because it naturally occurs with that. Remember when we spoke of polyatomic ions? Now polyatomic ions in this scenario usually form what is called your oxy acids or your oxo acids. But what we can, you'll have to learn those. But what we can usually tell you, if your polyatomic ions ends with 8, like your carbonate, usually the acid ends with IC, carbonic acid. Sulfate ion would give you a sulfuric acid. And then if your polyatomic ion ends with ite, like your nitrite, it will give you your as, which is nitrous acid. So that would be something you will have to learn and understand as you go. So I think that is it with molecular ions. I hope we had a good conversation and we'll bring our board back just so that we could start again. I didn't bring my board. I had to put things up so that I can speak to you, and I hope you'll subscribe and get to understand what we are talking about, because now we'll get to calculations and some serious stuff. Thank you for watching. This has been Basic Chemistry 101 with Sihlebonani. My name is Sihlebonani. Please subscribe, share the video, learn, and good luck with your studies if you are studying. But if you are not, let's share what we understand. Thank you very much. I wish now I could switch off the camera, but it's there. Man, I hope I'll come back for the next one. But hey, this is why we do this thing. This is for you. This is for everyone who has data to understand chemistry. Thank you very much.